come in terms of real life scenarios. Okay, real life scenarios. So you have the Singapore Flyer. Okay, is 150 meters in diameter. Okay, so think of a full Singapore Flyer is a Ferris wheel. Okay, the full circle is 150 meters. It makes one complete revolution every 32 minutes. At the highest point, passengers are 165 meters above the ground. They gave you the equation. Okay, they give you the equation. So just by what's given to you, what do we know? Forget about the equation right now. What do we know? What are some things, Tyler? Okay, so what was that? Say it again. Yep. So the highest, the maximum height is 165 meters. So your height is in meters. Okay. What else? Yeah. Okay, so one complete rotation is in 32 minutes. So by the time we finish one rotation, we're in 32 minutes. Okay, it's the whole time is 32 minutes. Well, on our graphs, we have 4 equal intervals. How can we determine that? What do we do? Yeah. Yes, we would. Because 32 minutes is the period. So to find equal increments, we divide by 4. So what's 32 divided by 4? 8. So we have 8, 16, plus another 8, it's 24. Okay? So, again, one revolution is the period, which is 32 minutes. We divide by 4 to find these key increments. So we know the maximum height is 165. Okay? The diameter is 150. So that's from the bottom of the wheel to the top of the wheel is 150. What else can we tell? Can we determine? What's the minimum value then? Would it be 0? No, Kennedy? 15 meters. Good. It would be 15 meters. How we get that is 165 minus the diameter of 150 to get the minimum value of 15. Because think of a Ferris wheel, you're not on the ground, right? You're above the ground. Okay? So, what else can we determine? Okay, I know the equation is given to us, but I want you to ignore that for a second. What else do we need in order to graph? Yeah, the midline, right? We need something in the middle. How can we determine that? Yeah. Good. Divide the diameter by 2, which is what? 75. Okay? So 75 is going to be our what then? Careful. Yeah. It will be our amplitude because what is our midline? 75 plus 15. 90. Okay? So our midline is determined by, we take the diameter, divide by 2, which is 75, plus the minimum to get 90 for our midline. But the amplitude, remember the amplitude is our radius, isn't it? Isn't the amplitude our radius? If you think about it? Yeah. So the amplitude is 75, which confirms our equation. Okay, do you guys see that? And we'll explain why it's negative in a second. 75, 150 divided by 2. So you take the diameter and divide it by 2. Okay. So Our amplitude is 75 meters, okay? The period is 32 minutes, okay? Now for this function, why it's negative? Because they're saying the lowest point, that's where you're getting on, okay? At 15, this is where you're getting on the Ferris wheel. Okay, that's why it's negative. Then at 8, we're here, it's a negative cosine graph. So one full rotation looks like that. Okay? So, we could tell what is the height, and we're going to skip around here. What is the height after 8 minutes? 90, good. 90 meters. What is the height after 16 minutes? 165 meters. Can anyone take a guess what the height is after 4 minutes? Yeah. Careful. Careful. It's okay. It's okay. Take a guess and jot something down. We're going to check it out in a second. Take a guess. What is the height after 4 minutes? Take a guess. Any ideas? Yeah. What is it? Okay. Anybody else? Yeah. Yeah, go ahead, Kay. Yeah. Okay. All right. Anybody else? Okay. I am going to go with 37.5 meters. It's okay. Here's why. 4 minutes. Is that halfway between 0 and 8? Okay. So that's halfway between 0 and 8. Okay, so 4 minutes is here, which is the halfway point. It would also, and this is an estimate, a halfway point between 15 and 90. What is the difference between 90 and 15? 75. Well, if we take 75 divided by 2, what do we get? 37.5. So we are approximating 37.5 meters after 4 minutes. So what is a way then, say if you were not sure, what is the way we could tell? How can we figure this out? Algebraically, say if you couldn't tell from the graph and you want to know exactly. Yeah. You could graph it. Okay, we could graph it on our calculators, right? What else? I want you to think. What does minutes represent in this equation? Not the period. You're right in terms of 32 minutes. So what would, say if I wanted to find what is the height after 4 minutes. If I had to substitute 4 in for something, what would it be? X, right? You could do that as well. So everyone take out your calculators, okay? You don't have one, I have an extra one up front. Okay. Yep. All right, one thing about your calculators though. What do you think we have to be in? Look at your equation. What do you think we have to be in? Careful. Look at your equation at the top. Radians because of pi. Okay. So to change your mode, go to mode, which is below window. Scroll down until you see radians highlighted. Hit enter, and that switches to radians. Okay. So mode, are we all doing this? Because you'll get the wrong answer. Okay. Mode, yeah, Camille. No. Okay. So we all should be in radians right now. Okay. All right. So now let's try it. So negative 75. And again, everything is a estimate right now. Cosine. Okay, you're going to need two sets of parentheses. The first one around the radian. So second, to find pi, it's below clear. Divide by 16. Right? Close parentheses. And then open it again for 4. Plus 90. Okay. We get roughly 37, which is in that ballpark. Okay, but I would take either. So what Kennedy said in terms of 37.5 and how we found it on the graph, that's visual by what we're doing. That's an estimate. This would be the exact. So either one would, they're fairly close, aren't they? 37 and 37.5 meters. They are. Okay. Does that make sense? Okay. I do want to show you what this looks like on the graph. Okay, so go into y equals and clear whatever you got in there. Enter negative 75 cosine. You need two sets of parentheses. Pi over 16 x plus 90. We have to adjust the window, so keep that in mind. Okay, everyone okay? And you must be in radians for this to work. We all good? Okay, so go to your window, which is right next to y equals. Your x min can be 0. Your x max is the period, so 32. The scale we're going to change to 8 because that's the increments we saw. Okay, so we want to mirror the exact same graph that we just graphed. Okay, y minimum, you could keep at 0. You could change it if you wanted to 15. I'm going to leave it at 0. The max, I'm going to put 165. Okay, then press graph. Okay. All right. So this is very similar. Okay. From the graph part, if you wanted to find x equals 4, okay, if we did second trace and press this value one, oops, and typed in 4, you're going to get the same thing as what we plugged in. Okay, so you could do that as well. And the value key is only for x. You're inputting x. Does that make sense? Okay. Everyone okay? So also to check if you wanted to do second trace value, say 16, you're going to get 165 at the top. Okay, make sense? Okay. So now, if we were to look at this next one, when is the Ferris wheel 80 meters above the ground? So look at your graph here, and then we'll get to the calculator in a second. Do we see 80 meters like as a definite value? We don't see that spelled out, right? So where would it be? Where would it be on this graph? 80 meters. Where do we think? Thank you. A little below 90. You guys think I'm asking a trick question? A little below 90. So looking at a little below 90, which you are correct, okay, how many times a little below 90 does it cross our graph? How many times do we hit 80 meters? Twice, right? So if 80 is here, we hit twice, okay? Roughly here and here. So what do you think we would have to do? And this is where we use our calculator. What do you think you would have to do to see where it intersects? What do you think we have done in the past? Any ideas? Yeah. Excellent. So you would have 80 equals your equation, negative 75 cosine pi over 16 x plus 90. And this is where you have y1 and y2. Okay? So we go back to our calculators. Okay? And go into y equals. And at y2, type in 80. Okay? And press graph. Okay, so you should see a horizontal line straight across. We have to find the intersection twice. Okay, so in order to do that, second trace, number 5. Okay, if you notice my cursor is at the top of the graph, yours might be too, but I'm going to move my cursor until it's close to that first intersection. Okay, move my cursor to the left. Okay, so once it's next to that intersection, you guys will probably reach it faster. You're going to hit enter 3 times. 1, 2, 3. So the intersection, that's 7.3 meters, the first one. Okay, so the first one is at, or minutes, sorry, it's in minutes. 7.3 minutes. And again, it's an approximation. Okay. Then we're also going to see the other side. Okay, so you have to do it again. Second trace, number 5, and now we're moving my cursor to the other side. Up. So now, the last question should be fairly easy. When is the Ferris wheel 165 meters? 16 minutes. So the way it's asking, just be careful with the questions, okay? Because that's what they'll do. They'll ask you for the height at a specific time, and given the height, what is the time, okay? So again, is anything new here? No, right? There's nothing new. The calculator we have seen before, however, now we're looking at sine and cosine graphs. That's all, okay? Let's check out another one, okay? All right. I'll set you guys up, and then we're going to do this. You're going to try it on your own, okay? The Ferris wheel has a diameter of 70. It takes 4 minutes to complete a full rotation. Passengers board a platform 10 feet above the ground, okay? So what are some things that you know? Yeah. Good. Our minimum is 10. Right, so this is height and feet. Okay. What else? What else do we know? Yeah. Good. The maximum is 80. How do we get the maximum 80? 70, which is the diameter, plus 10 gives you the maximum. Excellent. Okay. What would be the period? What is the period? 4. Okay, the period is 4. Okay, what would be my increments then? What would they go up by? 1. Okay, 1 minute, 2 minutes, 3 minutes, 4 minutes. Okay, now knowing my max and min, what would be the midline? Forget about the equations given to you, I see that, but what would be the midline? Well, the diameter is 70, yeah, 45. The diameter is 70. 70 divided by 2 is 35. 35 plus 10 gives you the 45, and the amplitude would be 35. Okay? All right. So go ahead and graph, and then answer the remaining questions, A through E. Okay? So we should have had the amplitude at 35 feet. I forgot to include feet. The period is 4 minutes. Okay? What is the height after 1 minute? What is the height after 1 minute? Let's see. Yep. 45 feet. Good. How about after 3 minutes? T, what do you have? Good. 45 feet. And Chris, after 4 minutes? 10 feet. Good. Awesome. Right. When is the Ferris wheel 10 feet above the ground? Everett? 1 minute. Oops. Nope. 0. The starting, right? 3 minutes and 4 minutes. So here it's the start and end. Okay. When is the Ferris wheel 45 feet? When's the Ferris wheel? Go ahead, Ave. 1 minute and 3 minutes. Okay, pretty good. Okay, any questions? Okay, we're going to do one last one in terms of Cape Cod. Okay, here they give you the shell of the equation. Okay, the tide in the Cape can be measured by using the scale on the pier. The highest mark the tide reached was 22. The lowest mark it reached was 4. A full cycle takes 12 hours. Okay, so we want to sketch a picture. Okay, pretty much what we did before, but they gave us the equation. Here they're not. Okay, they're giving us the shell of the equation, so we have to fill it in. So what do we know? What's given to us? Camilla. 22. It's okay. Okay, max is 22, so this is height in feet, and the min is 4. Okay, what else is given to us? Yeah. Good. So full cycle, which is the period, okay, is 12 hours. Okay, so our time is in hours, and we divide by 4. So we have 3, 6, 9. Okay. What else do we need to find out though? Yeah. The midline. Okay. So what can we do? Yeah. Good. That would be our what though? Yes. Excellent. So 22 plus 4 gives you 26, right? So that's our diameter, right? If we're looking at a Ferris wheel, but they're pretty much similar. But if we take 26 divided by 2, we get 13, which is our amplitude. What is our midline? Yeah. Yeah. Amplitude was 13. Good. Excellent. Good job, you guys. Excellent. Okay. So 22 plus 4 gives you the diameter, which is 26, okay? 26 divided by 2 gives you the amplitude of 13. To find the midline, 13 plus 4, okay? Now, we don't know if this is a negative graph or a positive graph. And I'm sorry it's split between 2 pages. If you look on the next page, okay, it says, right now, what would A equal? What's our amplitude, or our A value? 13. And what is our midline? 17. Okay, now, this is where it changes. Consider the low tide have occurred at 2 a.m., okay? So, we are going to start, and one of the rules of thumb is if they tell you that, if low tide is at 2 a.m., that is your starting point, okay? So low tide, what value would be low tide? 4. So if this is considered 2 a.m., I'm sorry to go back and forth, this is our low tide, okay? And it's telling us it's cosine already. So in most cases, you will see cosine unless you'll know the difference between the two. So from here, at 3, what value would I be at? 17, good. At 6, 22. At 9, 17. And at 12. Okay, so here is your equation. Here's your graph, sorry. Then on the previous page, do I have to adjust the A value? Because it's not saying amplitude, it's just saying A. What should that be? It's 13 correct, but what do I have to include? Negative, because we're not talking about amplitude, just the A value. So you're going to include negative, okay? So your equation is negative 13 cosine pi over 6, yes, x plus 17. Okay, so we're going to answer these questions together. When is the next high tide? I want you to keep that in mind. What times during the day will the water be 13 feet on the scale? Okay, now they're looking at times. So if our low tide was at 2 a.m., this would be what? What time of day? 5 a.m. And this would be? Good. Keep going. 11 a.m. And then we should end up at 2 p.m. Okay? That's only part of the day, but will it continue the same pattern? Yeah, it would. So, like if I looked at 5 p.m., what height would I be at? 17 feet. If I keep going, can't you figure out the trend for the rest of the day? Yeah, okay. So, I'll leave this on here and we'll answer the question so you guys can look at the graph above, okay, or right here. All right. When is the next high tide? So if this is our low tide at 2 a.m., when is our next high tide? Yeah. 8 a.m. When would be another time after that? Anybody? Yeah. Excellent. 8 p.m. Okay. So it's a 12-hour difference. Okay, if you continue the trend. So write down for the next high tide, 8 a.m., and then put the next one after that at 8 p.m. so you could see how it continues throughout the day. Make sense? Okay, you guys are good. Then what times during the day will the water be? Should be 17 feet. Okay, 17 feet, not 13 feet. 17 feet. Change that 13 to 17. Yep. It would be 5 a.m., right, first? Yep, 5 a.m., 5 p.m., correct? Excellent, good. Yeah. Did we switch that up? I think we did. 13 would be the minimum. Now that I'm thinking of it, wow, good. It took this long to figure that out. Why, Tate? Why would that be? So the amplitude would be what? Then 9. Okay. So my bad on that one. Okay. I was thinking too fast and going through this, rushing. So change here. You guys should have corrected me. You did? I didn't hear you. See? Just convince me more. Thank you. Sorry, Kennedy. See? Mistakes happen, right? Mistakes happen. I think too much sun this weekend. Sorry. My bad. Okay? So 13. So go ahead and change. Yay. 13 is your midline, and 9 is your amplitude. Yeah. I knew something looked weird because I did this one in previous class the right way. Ay. Okay, cross that out. That is losing her mind. Officially. Okay, amplitude, -9. This, 13. I knew it looked weird. Okay. All right. So you guys are smarter than me. All right, so that's right, 13 feet. So next high tide, 13 feet was, now let's go back. 5 a.m., 11 a.m., then what else? What would be 5 p.m. and then 11 p.m.? Do we agree? Good. So let me write this. 11 a.m., 5 p.m., and 11 p.m. Okay. What will the height of waves be at 5 a.m.? The correct answer now would be 13 feet. Good. Okay. What will the height of the waves be at 8 p.m.? 22? Yeah. Yes. It's hard not seeing the graph in the front because this is 8 a.m., 12 hours longer. Good. Excellent. Okay. So sorry about that little fudge on my part. Okay. Call out, and again, I didn't have anything in front of me, so that's trying to remember and not screwing things up. So I apologize. Does this make sense now, though? Sorry about that little fudge. The halfway point should be your midline, okay? Should be your midline. The amplitude is the distance between your midline and your max and midline and your min, okay? So your practice, you guys already started it in class, okay? Which was the page 14 through 16, okay? A little of the graphing recall. Some of you might be done already, which is great, okay? Some of you might have a little bit left to do. But again, the more you do with graphing, the better it's going to become, okay? So that is your practice. Why aren't we answering those questions? I didn't write them on the board because we talked about it.